So far we have been talking about the networking resources. So, if we look at the technology platform for e-business, we have in the networking infrastructure, we have this networking protocols, and along with that we have networking hardware. So, when now while talking about this hardware, first thing that we are going to talk about is your networking hardware. Then we will be talking about the computing hardware, various storage options, then the software resources. Now, if you remember our ISO OSI model, which is a 7-layer model, and last class we also mapped it to TCP/IP. Now, let us see what are various hardware devices in each layer of the protocol. So, first thing is that in the physical layer you have repeaters and transceivers, then in the data link layer you have switches and bridges, then in the transport layer you have in the network layer you have your network and transport layer you have your routers, then for upper layers you have gateways, then there are certain bridges to routers. Let us try to see what all of them, what is the functionality of each of them. So, first one is a transceiver. It provides the means for encoding the data into purely electrical and light signals, and which is ready for transmission into the physical media. Now, look, if you have different kinds of physical media. It can be coaxial cable, it can be optical fiber cable. So, depending on the type of physical media, the signal need to be changed from the data. Signals is basically what? The data packets that you are sending ultimately has to be converted either to electrical signal or to the light signal, depending on the media, or it can be converted if it is a wireless protocol. We are not right now not discussing, then it has to be converted to appropriate form, so that through the media it can go. So, it is the transceivers who does it. Then they are also responsible for converting the signals back into the data at the receiving stations. Your network adapter cards are actually examples of transceivers. Then the other element in the network is your repeater. It is used, these repeaters are used to extend the LAN. If, as we have already discussed, while passing through the media there can be data loss, the packets may be lost, or they may be, after all they are signals. So, they may be lost or they may be weak, they may be distorted. So, the repeaters are added within the network in if the distance is more, to regenerate the frame. So, they must be compliant with maximum acceptable delay in the network. They are mostly not very intelligent, but some are semi intelligent, they have memory and they can help preventing the errors in the form and collision of the form. Ethernet is your one example of this. Then you have bridges. These bridges offer filtering and forwarding capability based on the layer 2 field and independent of the layer 3 protocol. This filter, they help in filtering and forwarding. They have this filtering and forwarding capability on layer 2 fields to increase the backbone efficiency. This traffic management capability, they have the traffic management capability at the link layer. They can associate the node to the corresponding MAC addresses with particular interfaces and forward them. They are responsible for preserving network topology and integrity by stopping the formation of loops. So, such protocols they use protocols such as spanning tree and its variant, so that the frames which are sent over the internet are not come back to the same location. Then you have switches. They are used when there is a need for higher bandwidth in the shared access LAN. In fact, these switches and bridges are does almost the same thing. They are high speed bridges. They are the replacing old bridges and repeaters. Then you have routers. These routers, as I told you, when we look at the TCP/IP protocol stack, the lower two layers are implemented in the routers. They are special purpose layer 3 devices used instead of a host. In fact, while discussing about dynamic load balancing, when we were discussing about web based systems, when the load becomes very high and you have multiple servers, that time also I mentioned that the routers are the devices. Sometimes they can map the IP address to domain name conversion when it is used. Instead of the IP address of a particular host, the IP address of a router is given, which means each of the router has one IP address, and they are intelligent enough to divert the traffic to a corresponding server in case of load balancing. Now, these routers they forward network traffic based on IP address rather than based on MAC address, but the lower level it is the MAC address. Then they communicate with one another, learning the neighbors, routes, cost and addresses, and select the best path routes for routing the individual packets. Now, they are scalable and can support very large internetworks in terms of both load and addressing, and they require skilled maintenance staffs to maintain them. Then gateway is a very generic term. Any network device that is capable of protocol translation when two different protocols, two different networks with variant of protocols are connected, such devices are called gateways. They are just transport relay devices. Sometimes they are also mentioned as routers themselves. Now, we are going to talk about the computer hardware platform. See, while talking about the resources, the first thing that we have talked about is a server. Server is the basic element. By server we mean the hardware server. In fact, in the earlier class I have told you, when we talk about the server, there is a hardware part of it, there is a software part of it. By hardware part we mean actually the physical server. Within that physical server you can have a web server or HTTP server, which is a software. You can also have a database server, which is also a software. You also have an application server, that is also a software. So, the one that we are right now talking about is that hardware server or the hardware platform. The server that we are talking here is the hardware server. So, different computing machines are part of your EBNS infrastructure. Your client machines, which can be a PC, which can be a mobile device, which can be a laptop. Similarly, you can have servers which can be of many types. Then you can have mainframes. Then you can all these servers contain the basic chips, the processors which are produced by the companies like Intel, etc. And there are many firms which use this chip the hardware chips to finally make the server. The companies like IBM, HP, Dell, etc., they make the server. Now, a computer, what is a server? What is a computing server? The computer that provides services to other computer or the software that runs on it can be termed as the server. So, server is can be the hardware or it can be software. So, there can be many types of servers, there can be application server, database server, your fax server and so on. They can be all of them can be part of your business infrastructure. Then when you buy a server, many factors are actually responsible for this. We have arranged it from most important to least important. First thing is that it should be supporting the application that your company requires. Second important element is the cost. Third is the ease of administration. Fourth one is familiarity with a similar range of systems. Homogeneity, by homogeneity we mean if we are buying a new server, it should be actually be compatible with your existing systems. Then interoperability, if there are other systems in your organization or in your business partners organizations, then this particular server that you are buying should be providing you the support for interoperability. It should be reliable, it should be scalable with proper security, etc. There are certain servers which are more prone to virus attack, etc., and certain servers are not. Then the another important fact is actually vendor support, though it is of not very high priority, but this is of priority as well. If you have a good vendor support, then your maintenance problem, etc., can be taken care of. Now, when we buy a server, in fact, in the very first lecture in this series of infrastructure and e-business, we understood that the performance of a server can be measured through response time. Customers over the internet cannot really wait if your server is slow or your website is slow, and that time we discussed there are many factors responsible if a website is slow. Your server is responsible, your ISP can be responsible, your network can be responsible, even your client machine can be responsible, but it is the server which is the most important. At least it is, we have the control over it, and we should be buying a server with good response time. Now, what exactly this response time is? This response time, also known as the last time, this lapse time or wall clock time or execution time or latency to complete a task. This includes the disk access time, memory access time, input output activities, operating system overhead and so on. So, which means whenever a request is, just consider the example of a HTTP request. When a HTTP request is sent to a web server, then the web server in turn will be if it is a dynamic page, it might be the web server will be contacting the application server, and the application server in turn will be contacting the database server. Besides these server activities, there will be operating systems involvement as well, operating system overhead, there will be frequent memory accesses. So, all these things together define your execution time. Then within the computing devices, you have a CPU, the central processing unit, and this is the main part for making the computations happen. So, the CPU time is a major part of your response time. So, your CPU should be powerful enough so that and powerful, and your operating system should be capable that CPU does not wait for IOs for running other programs. This CPU time can be broadly classified into either user CPU time for running a single program, or the system CPU time, which includes not only the program running time, it is the also includes the operating system overhead over running the program. Now, when you buy a system, specifically a server, a system's performance is referred to as the elapsed time on the unloaded system. By unloaded system, we mean no other program runs at that particular time, only a specific program for which the performance is to be measured runs. Then the CPU performance refers to the user CPU time on the unloaded system. Now, this response time of a system not only depends on the CPU time, but it also depends on the IO time. By IO input output time, we mean your system is connected to many input and output devices. So, while making a choice of the server, only CPU time is not important. If a request, if a program is running and it in turn requires accessing the IO devices, it has to wait, and if the IO devices are slow, then that waiting time will be more. In fact, it is seen that if you have suppose we have a difference between the CPU time and response time of 10%, and we speed up the CPU time by a factor of 10 while neglecting the IO, then we will get a speed up only 5 times more. It will not increase by 10 times 10%, with half of the potential of the CPU wasted. Similarly, making a CPU 100 times faster without improving the IO would obtain the speed up of only 10 times, and wasting 90% of its potential. Thus, IO performance can reduce the CPU's performance. So, while deciding a server, it is not only the CPU's characteristics, but its IO characteristics also need to be understood. While making a purchasing decision, generally the cost is held constant, because cost is a major constraint, as we have discussed that what are various parameters to choose. The second important parameter is actually the cost. So, keeping the cost constant, the system's parameters are adjusted. You decide about various elements to be added to your system, keeping this cost constant. The speed and storage capacity are adjusted to meet the cost target. Now, as I have told you, it is important that you have a CPU, you have a high speed CPU, but your connecting supporting devices should also be fast. Specifically, your memory plays a very important role. This memory is actually realized in the computer's memory in terms of a memory hierarchy. In this hierarchy, first you have nearest to the CPU, you have these registers, then you have the cache, then you have the main memory, then you have the disk memory. The fastest memory is near the CPU and the slowest memory is farthest from the CPU. So, in high speed machines, the signal propagation is a major cause of delay. Now, large memories have more signal delays and require more levels to decode the addresses. So, therefore, to keep it simple, near the CPU, the fastest memory and the smallest memory is kept. In most technologies, we can obtain smaller memories that are faster than the larger memories. This is primarily because designer can use more power per memory cell in smaller design. Now, fastest memories are generally available in small number of bits per chip at any point of time, and they cost substantially more per byte, and they are kept nearer. The fastest memory elements are kept nearer to the CPU because due to this principle of locality, the same program code on the same blocks of data are going to be accessed. I mean, the nearby blocks of the data or nearby parts of a instruction can be accessed immediately. So, the first element, let us have a look at this memory hierarchy once again. First is your CPU, then is your cache memory, and CPU has its register, then you have cache memory, then you have main memory, then you have your disk memory. Then this cache memory is the smallest and fastest memory located close to CPU that holds the most recent address codes or the data. When it is when the CPU, if some data is not there in the register, when CPU searches, it first searches in the cache. This, if it is the data is available or the data or instruction is available in the cache, it is called a cache hit, otherwise it is a cache miss. Because of this temporal locality, we were discussing about this principle of locality. This principle of locality can be temporal locality, which means the data which is accessed now, in the near future it is going to be accessed again. And this special locality says, if I am accessing a small chunk of data after the data which is immediate to this I am next going to access it. So, the time required for cache miss depend on both the latency of memory and its bandwidth, which determines the time to retrieve the entire block. This cache miss, which is handled by the hardware, is usually caused the CPU to pause or stall until the data is available. So, therefore, most used data has to be kept in the cache. Now, if the data is not available in the cache memory, they will be going to the main memory, and if they are not in the main memory, if the main memory is not adequate, then maybe a part of the secondary memory can be used as a virtual memory. So, if it is not available in your RAM or in your main memory, then page fault occur, and if the page fault occur, then disk access has to happen. Now, these secondary storages can be in various forms. First one is your magnetic storage, second one is your semiconductor storage, it can be optical disk storage as well. This magnetic storage is your main memory. While the main memory is volatile, all these secondary memories are non-volatile. This also this magnetic storage, which can be a magnetic disk, magnetic tape, etc., all of them are non-volatile in nature, and the data can be stored in them and can be accessed in future instances. This semiconductor memory is also a permanent memory, which contains millions of tiny transistors or capacitors. They come in both volatile and non-volatile form. In fact, the volatile part of it is kept in as the main memory, and non-volatile part, today you see your pen drive, etc., they are actually semiconductor memory. Then next is your optical disk storage, which is your CD-ROM, etc. While talking about these memories, they actually differ in the way the data is stored in them. In case of magnetic memories, the data is stored by the different magnetization patterns, on a coated surface, on a surface which is coated by some magnetic material. Whereas, in case of semiconductor, it is the transistors which are actually responsible for storing the data. In case of optical disc, which is again non-volatile in nature, it is the information is stored in a different manner. It is by illuminating the surfaces with laser diode and observing the reflection, and while storing the data, it actually you must be knowing that you have to burn the CD. By the burn the CD, we mean we create different patterns which can be afterwards read using by illuminating the surface. Then another category of storage devices which are actually responsible for keeping your organizational data is your network storage devices. They are not part of your, they may or may not be part of your computing, they are in fact not part of your computing system. They are separate memories to which your computer can access. This network storage is any type of computer storage that involves accessing the information over communication network. These network storages allow to have a centralized storage of information in the organization to reduce the duplication of it. There are three types: direct attached storage, network access storage, and storage area network. In case of direct attached storage, which is a basic form of storage, the storage devices are part of the host computer as drives and directly connected to a single server with this RAID arrays and all. About all these details we are not anyway going to discuss, but they are additional secondary memory, additional drive attached to a server. This network workstation must therefore access the server in order to connect to this storage device, which means there will be a server. With that server, this device will be attached. Other computers in the network can access the server first, and through the server they can access this direct access storage device. This network access storage devices, in contrast to your direct access storage, they have their own IP addresses, and other computing devices in your network, if they would like to access this storage device, they need not go to a specialized server, which is in case of your direct access storage. So, this enables multiple computers to share the same storage space at once, which minimizes the overhead by centrally managing the hard disks. So, NAS systems usually contain one or more hard disks, and they are often managed in logical redundant storage containers or RAID arrays. Then almost any machine that can connect to LAN can use this network file system or this common internet file system or HTTP protocol to connect to these NAS devices and share files. A NAS allows greater sharing of information, especially between different kinds of, it has the capability of connecting to different kinds of operating systems as well. Then the next category of network storage device is storage area network or SAN. This is very similar to the NAS. However, the difference between NAS and SAN is NAS you can your computing devices can access NAS over the same local area network to which other computing devices are attached. So, it has one IP address and everybody all other computing devices can access NAS. However, in case of SAN, that is storage area network, you have to have specialized storage network and every computer has to be connected to this specialized storage network. So, which means you have to be investing additionally along with this along with the storage, the network, a specialized design network which has to be built for managing, for connecting to this storage. So, because of this additional cost, this network, this new network will be built only for server class devices using some optical fiber channel. Now, this SAN file sharing system is it is again operating system independent, dependent, and it does not exist in many operating system. So, if at all you are getting a SAN system, you also have to have the right kind of operating system. And again there is another restriction, the length of the fiber channel to which this SAN computing devices need to be connected is limited to maximum 10 kilometers. But the benefit is the faster communication. In case of NAS, you have to communicate with your networking device through your ordinary LAN, which means if there is any network congestion etc., there will be communication, there will be data loss or similar problems. This is where we show the major difference between this NAS and SAN. Both are actually connected to the network. In case of NAS, it is scalable, the data can be transferred over long distances, it is slow and it has the problem of congestion because you are using the same LAN. Then inefficient data backups and recovery, because it also depends on DAS devices for this. Then you have, in case of this is in case of NAS. In case of SAN, you have efficient data integrity, backup and recovery, and faster, no congestion because it is a specialized network. It is costly and not easily available, and data cannot be transferred over a long distance. Here the maximum limit is 10 kilometer. Now, we talk about the computer software resources. In fact, we will not be spending a lot of time on this. Your computer software is actually can be either application software and system software that we have discussed, but one important, and all these application layer things, most of them in the application specific programs we have already discussed. Programming language etc., we are not going to discuss. Only important element here that we need to know little bit more about is your operating system. Your operating system is a collection of programs designed to manage a system's resources like your memory, processor, device, information etc. Now, this operating system keeps track of the resources and shows and decides when to use and how much to use while sharing the resources among various processes. These are the typical functions of operating system. it has one user interface through which people can be communicating. This can be a very good user interface like that of Windows, or it is some for in case of Unix systems, it may not be a very user friendly interface, but there has to be some interface. Then it has 4 functionalities: resource management, managing and using managing the use of the hardware resources, then task management, which is about managing the various tasks given to the operating system, then file management, it is about managing data, program file, etc. Then providing utility other utility functions like providing various support services. So, with this we finish this lecture, and from next class onwards we will be talking about the data resources. Thank you very much.